Thanks for dropping in. It's the time of year where I design some sort of 3D printed heart-themed container, using whatever mechanism I randomly pick. The tradition started with the lovely puzzle box, which only opens when you twist it into a heart. And more recently, I created this 2-chamber shutter box, which makes use of a fully 3D printed sliding door. This year I designed the Openhearted Box. This model incorporates tricks from both of those older designs. Like the lovely puzzle box, it stays firmly locked until you reveal the theme. The lid swings to the side and snaps into a heart with a satisfying click. And like the shutter box, this model is fully 3D printed, no hardware required. So let's assemble another print, and I'll show you exactly how it works. We'll need 2 identical copies of the main box body and 2 identical copies of the lid. For best results, you'll need to use a filament with good mechanical properties. PETG and regular PLA should be fine, but some of the fancier PLA mixes, like silk and matte PLAs, may be too brittle. Try those at your own risk. The parts themselves are easy to print. They require no supports, and if your bed adhesion is on point, they don't even need a brim. In addition to the 3D printed parts, you might also need a small clamp, because assembly requires a bit of force. Before we do the actual building, let's test fit just 1 copy of the lid and the main body. When properly aligned, the raised circular section of the lid should fit within the hole of the main body. Pay close attention to the 4 registration circles in the lid, because those are going to define the 45-degree angle you'll need to match when sliding the parts together. With a little force, the flexible latches on the main body will move aside, and the 2 parts will lock. You can now swing the lid back and forth to check that the mechanism properly snaps between its closed and open states. That's all we needed to test, so let's separate these 2 parts and we'll get back to the actual assembly. First, take both sides of the body and line them up so that the raised internal snaps on one side match the inset sections of the opposite side. I found it easiest to angle the parts together like a book, and then slowly squeeze them together. Once you hear one half snap in place, you can work your way around toward the other end, or finish the job with a clamp. Next, we'll repeat the process with the lids. This will be easier since there are fewer snaps to line up, but that also means the lid might not hold together as strongly. If the parts feel loose, add a little glue around the snaps to make sure you get a really good connection. Now we're going to slide the lid onto the container body. The 2 arms for the lid should be able to flex a bit as they slide on. And remember that test fit from before? We'll need to replicate that 45-degree angle. With proper alignment and a little push, the lid should fall into place. And the box is done. If all went well, the lid will be free to swing between the locked and the unlocked positions. But the hidden flexible latches will offer enough resistance to keep the container closed. I know from similar models in the past that these are the sorts of designs that are most likely to get some heartfelt personalizations. So if you customize your own print, or even if you print the plain unadorned box, I'd love to see your results. Until next time, happy printing, and thanks for stopping by. Thanks for sticking around to the end. Since you did, here's a little bonus model for you. By request, my little posable snow people, penguins, seals, and bears have a new hat option, a graduation cap. With a little sewing thread, you can even add a small tassel. It's a little early in the year for this print, but I figure a few people out there are already making plans to celebrate the upcoming graduates. And as a person with a 3D printer, I figure that's as good a reason as any to fire up the machines. Alright, see you next time.